In the last video, we talked about some of the properties of real numbers, and now we're going to kind of expand on that a little bit. The number 0 is very special in addition and is known as the additive identity. And the reason it's special and the reason it's known as this is because for any number a plus 0 is equal to a. Adding 0 doesn't actually change anything. In addition, everything has a negative, so that a plus its negative is equal to 0. And these are the properties for something to be an identity. Subtraction is the operation that kind of undoes addition. So to subtract a number from another number, we add its negative. So essentially, what subtraction is really saying is a minus b is a plus negative b. It's letting us add the negative. So let's look at a few properties that have to do with this. Our first property says that negative 1 times a is equal to negative a. Actually, multiplying a number by negative 1 changes its sign. Negative negative a is equal to a, so double negatives cancel each other out. Negative a times b is equal to a times negative b, which is negative ab. Essentially what this says is that if you multiply a negative and a positive, you get a negative. Negative a times negative b is ab, or multiplying two negatives gives you a positive. Negative a plus b is negative a minus b. You can distribute a negative sign. And negative a minus b is the same thing as negative a minus negative b, which is negative a plus b, or b minus a. So let's do some examples using these. Negative y plus 5. I could rewrite that as negative y minus 5. If I have negative a minus b plus c, I could rewrite this as minus a plus b minus c. A negative sign out front essentially is going to change the sign all the way through. And just like 0 is special in addition, the number 1 is special in multiplication and is called the multiplicative identity. And it's called this because if I multiply any number by 1, it doesn't change anything. I get that number back out. In addition, we have inverses when it comes to multiplication. We had negatives in addition. With multiplication, we have the inverse, 1 over a. And this satisfies the property that a times 1 over a is equal to our identity. Every single number has an inverse with the exception of 0. And division is really defined as multiplication by an inverse. A divided by b really means a times 1 over b. Once again, provided b is not equal to 0. Some quick notation. Most of the time, we don't want to write a times 1 over b. Instead, we write this as a over b. And this whole thing is called the quotient. It's also the fraction a over b. The number a is the numerator, and the number b would be the denominator. So, let's look at a few other properties of this multiplication and division. Our first property says that a over b times c over d is ac over bd. When I multiply fractions, I multiply the numerators and I multiply the denominators. The top multiply the top over multiply the bottom. When you divide a over b divided by c over d, it's the same thing as multiplying by the reciprocal. When we divide fractions, we take the second fraction and flip it over, and then we multiply. If we look at addition, if our denominator is the same, then we can just add the numerators. However, what if our denominator is not the same? What if I had a over b plus c over d? We can do this by a times d plus b times c over bd. We need to find a common denominator and then add the numerators. Our next property, AC over BC is equal to AB. If we have something that's the same on both the numerator and denominator, we can cancel it. And then the final one, A over B equal to C over D. Then, if that's true, AD is equal to BC. We can cross multiply. So, now that we have these basic properties, I do want to point out one important thing. When adding fractions with different denominators, while we can use this property and it will always result in something, we typically don't use this property. Instead, when we try to find our denominator, instead of just multiplying them, we actually want to find the least common denominator. As an example, if I want to add 7 over 36 plus 5 over 120, I really don't want to multiply 36 times 120. Instead, I could multiply this first fraction by 10 over 10, and this second fraction by 3 over 3, and have a common denominator. And while this still needs to be reduced, it's a lot better than dealing with 36 times 120.